Okay, so over the next couple classes, we're going to wrap up chapter 3, chapter 3, with two major ideas. In fact, they're so major they're called laws. The one thing we haven't talked about when we're doing all this triangle stuff and trigonometry stuff is what happens when it's not a right triangle. Everything we've done so far, sine, cosine, tangent, involved using a right triangle. There are methods to solve triangles that are non-right triangles. You're going to need your calculators, by the way. If you don't have them out, you can snag those bad boys. So normally, if I gave you this problem, you would say, that's not solvable because it's not a right triangle. How do we know it's not a right triangle? Well, I'll ask you a question. And the question is, tell me how big that angle is, please.
100.
It is 100. Who said that, by the way? Thank you, sir. How'd you get that?
33 plus 47 is 80. And then 180 minus 3.
Perfect. Okay, not a right triangle, so we're all in agreement there, right? Again, don't trust the picture, but the numbers show that that is not a right triangle. So how do we solve it? Well, we're going to use two different methods. Today, only one method. We'll get that one, what's called the law of sines, under control. And then on Friday, we'll talk about the law of cosines. They each do something different. In order to use the law of sines, we need to have one relationship in the triangle. And that is, you need to know an angle and the side opposite it in order to be able to solve the problem using law of sines. So you'll notice in this triangle, I've got this angle, and I know the length of the side across from it. So therefore, I can use the law of sines. Once we learn the law of sines and the law of cosines, you're going to use that indicator to decide which method should I use. That's going to be the big deal. Today it's easy. Everything's law of sines. Law of sines, law of sines, law of sines, law of sines. When you throw law of cosines into the mix, things get a little wonky because you got to figure out which one to use. So again, that's the indicator that we should be using the law of sines. Okay, and I know the anticipation is killing you. What is the law of sines? That is the law of sines. Okay, now, from a mathematical standpoint, this is bad. Two equal signs, not a good idea. What you're going to do is pick and choose which two you want to use. So let's say, for instance, I know stuff about A and B. Then I'm going to get rid of that and just do that. Okay. Or I know something about A and C, then I'm going to get rid of the B part. And then, of course, you're all bright enough to realize that the third scenario would be if you have B and C, you get rid of the A part. So you take the chunks out of that law that you need. And that just reiterates what I already said. You have to have an angle and the side opposite to proceed. Okay, we ready? Yes? All right, here's our first example. Let's go back to that guy. We're going to solve for x. Even though I did it already, I'm going to repeat myself. Can I use law of sines here? The answer is yes. I have the angle 47, and I have the side opposite it of 14. Therefore, I should be able to set up the law of sines. The sine of an angle over the side opposite it equals the sine of an angle over the side opposite. Go ahead and solve that, please. for the rest of you, would it be helpful if I made these slideshows available before class? We could take notes on the slideshows? All right, I'm on it. You'll have to remind me a little, because it's not a habit I'm in. It's not a habit I'm in? That doesn't make any sense. But I will try to be better. When you're done, ask yourself a simple question. Does my answer make any sense? So for instance, will x be bigger or smaller than 14?
Smaller.
Smaller, correct. Because 33 is smaller than 47, so x must be smaller than 14. Working. Let's proceed for Kansas. What are you doing there? You got cross multiplier. What do we got? That is the correct answer, but that's it. Right now you have to solve it. Okay, so a couple things about solving this, and I'll do the actual math in a second, but I know a lot of you are just cranking this out on your calculator. Remember, I can't grade your calculator. So when you set up the law of sines, I need to see the next step, not just all of a sudden having an answer up here. What is the next step, by the way? How do I solve this? Cross multiply. X, whoops. What just happened? X times the sine of 47 equals 14 times the sine of 33. Remember to put the numbers and the variables in front of the function so that it doesn't accidentally get wrapped up into the trig function. Divide both sides by the sine of 47, and I get x is equal to 14 times the sine of 33 over the sine of 47. Okay? And remember, you can't get that 33 out of the sine. Just having something that says sine doesn't make any sense. It's got to have the sign of something. Plug and chug. Number of you already said something about 10.4. Does that answer make sense? Yes, because 10.4 is less than 14. Questions? Oh, baby. Suppose I asked you to solve the triangle. What would you do next? In other words, we already know what A is. Sarah helped us with that earlier. What she said it was 100. Mm-hmm. Okay. How would you find CB? Let's call it Y. Martha.
You could do sin 47.
I'm sorry, do what?
Sine.
That's what I thought you said. Yeah, just check it.
47 over 14 equals sine 100 over x.
Or Y.
Or y.
Yeah, perfect. Okay, good. Questions? There's one other type of problem that we need to look at, and then we're done. That's it. Is it safe to assume that this is fairly straightforward and easy? Yes? Good. Oh, here's all the work. Yeah, I should. Okay. Now, here's the second type of law of sine problem, and that is when we got to use it to solve for an angle. Okay. So again, going back to the very beginning, can I use law of sines here? The answer is yes, because it's in a law of sine slideshow, and I have an angle and the side opposite it. Okay. Am I going to solve for angle A or angle B first? And this isn't a preference. There's only one answer to this. A or B? Martha?
A,
Why?
because the side opposite of it has a number.
Perfect. Sine of 25. Sine of an angle over the side opposite that angle is equal to sine of the angle over the side opposite that angle. Exact same setup, solving for something different. Go ahead, solve it. And yes, you will need to do an inverse sine at some point in time. So leave it over there for now. No. Just get rid of the sign for 5 minutes. Leave it 5 in the denominator. You divide it by 5 already. You gotta leave the sign in front of the A. Now, use your lasso. Take that whole rational expression and move it over to the whatever, more, that's good. How do you get 8 by itself? 10 divided by sine. Goes up into sine, the whole side. No, that's a reciprocal, inverse sine. I understand. Don't hurt yourself. Anybody? I knew this would cause some problems. Okay, so walking around the room, I saw this. That's a good start. We also know that as cross multiplying. Then I saw this. We're good so far? Okay, then I saw some really bad math. So I saw some people dividing both sides by sine. I saw some people just erasing the sign. I saw some other thing. How do I get rid of that sine?
Inverse sine?
Inverse sine. So I have to take the inverse sine of this side and the inverse sine of that side. These are going to cancel each other out, leave me with a this mess. I typed that whole thing into my calculator in one fell swoop. Be careful with parentheses. So you're going to need to put parenthesis there and there. See what you get for an answer. Will A be bigger or smaller than C? Bigger. Good. So you better get an answer bigger than 25.
I just solved this and then
Because whatever you want.
it's just the same thing.
All right, 49.5, yes? All right. And as we talked about, 49.5 is an approximate value. It's actually 49.53 or whatever it was. But to make our lives easier, we're going to use that number to calculate how big angle B is. So 49.5 goes here. Angle B then is 180 minus 25 plus 49.5. However big that angle would be. Okay? And then once we have angle B, we could go and find side B, but that's not what I asked you to do. I just asked you to find A and B. That's it from law of sines. Law of sines, you use it to find a side. Those are the easier ones. That's what we did first. Or you use it to find an angle, which is causing some problems for people because it's been a while since we've done an inverse sine calculation. Okay. Questions? Anything that needs clarification? Going once, going twice. My clicker's not working and I just threw my pen. Gracias. Now, before I cut you loose, there is one thing I want to talk about, and that is I want to go back to the mountain problems. Oh, shut up. I want to go back to the mountain problems, and all I hear is... Okay, so...
It's only Wednesday.
Okay, so going back to the mountain problems, which I know you love so much. When I first introduced the mountain problems, I said to you, how many triangles in that picture? And you told me 3. How many of them are right triangles? 2. So one of them we had to stay away from, which was the non-right triangle over here. So if you'll recall, the problem looks something like you go to the point B, you measure the angle up to the top of the mountain to be 27, you back up 4 miles, you measure the angle again to be 32. You had to set up a couple tangent equations and go and do all those calculations to find the h. However, now we can play with this pink triangle. But notice, as is, I cannot use the law of sines because I don't have an angle in the side opposite it. So what I wanted to talk to you today is about this very briefly is how to find the angles. Let's start with the easy one. How big is that angle?
153.
153. How big is that angle?
Five.
Oh, wait, sorry. I screwed up. I'm an idiot. Let's back up. My angles were wrong. This would be 32. This would be 27. That's better. Okay, so this would be 148. There we go. That'll make more sense. Because all of a sudden the angles were adding up to be greater than 180. Yes, sir. 5 degrees. Is that right? 160, 175, 5 degrees. How big is this angle? No.
58.
58. So notice, now with the pink triangle, I can use the pink triangle to solve for this distance, and then I can use that distance to solve for h. When you do this problem on the homework, and you use the law of sines, I think you'll find it much easier to solve versus the two big scary tangent problems. We good? All right, that's all I got for you. Let me do this, exit here.